Welcome to Spring Lib.
So once again, we are dealing with a new set of problems, or rather just a new problem, if you want to think of it that way. And this particular problem highlights the relationship between the angle and the intensity of light. And here we're looking at the maximum intensity of light. So this is going to be our I, that's the intensity, and it's coming off of a slit. Um, and this is a single slit. Assume that this slit is adjustable such that there's obviously light going through the slit and landing on a screen and producing specific intensities, as you can see depicted by this diagram. The next part would be, or what would happen if, for example, this slit that we have, we doubled the size of that slit. So now the slit doubles. What's going to happen to the intensity of light? That's what we're looking for. Remember, this is diffraction going on in this particular problem, and our goal is to see what happens when we double the slit. If you double the slit, you're seeing what's going to happen. The doubling of the slit increases the intensity 4 times. So this intensity right here increases 4 times if the slit is doubled. If you're thinking of doubling the slit, the reason why this happens can obviously be depicted in specific steps. We have to explain, why is it that when you double the slit, the intensity I goes up by 4 times. So there are a couple of things happening. If we think about a single slit diffraction, you can see that there's facing taking place, and one face angle phasor estimation would look like this. So it would look like this. This would be the radius, and then this is our alpha, and this is our amplitude A. That's our amplitude. And so we have an initial amplitude right there, and the that's the phasor diagram. Okay, this is the phasor diagram, just to show what happens with the changes in the intensity and the amplitude. How does the amplitude change? So we're going to go ahead and solve the problem. Our main thing is, why is it that if you double the slit, then the intensity quadruples? That's what we're thinking of. Doubling the slit. How does it affect the intensity of light in this particular problem? So the first thing we're saying is that the slit width, I'm going to call it A. I'm going to call this A. And the screen is on this side, so the minimum intensity, we're going to call that IM, M for minimum. And so at theta, if you can recall in our previous diagram, we have theta on the x-axis and then the intensity on the y-axis. So at a specific theta, our intensity is I theta. So this is I theta. The y-axis is I theta, and I theta can be equivalent to Im, which is the minimum intensity, then sine alpha over d. Remember, d was the diameter, if you can recall. D is the diameters that we're dealing with. Alpha is depicted in this face angle right here. So this is alpha. It's very abstract, and assume that alpha is pi over a lambda sine theta. Remember, theta is the angle we're dealing with that produces the intensity. A is the slit width. This is the angle. A is the slit. This is the wavelength. That's the wavelength. And we do know that the amplitude is a factor of the initial amplitude times sine alpha over alpha. That's the amplitude we're dealing with, because intensities produce amplitudes, and also we know that A equals to Ka sine alpha over alpha. So you can see that our initial amplitude is a factor K times the width of the slit. The amplitude is proportional to the width. So if you increase the width, you're going to increase the amplitude. And the intensity is proportional to the amplitude squared. So those are relationships that are helpful in solving this problem. The ratio of one amplitude to another one is given by the ratio of the widths of the slits squared. So if this is A1, that's A1, then there's going to be an intensity on the screen of I1. If this is if the second one is A2, there's going to be an intensity on the screen of I2, and the relationship between these two is given by the square, and A2 is 2A1 because we're doubling. Remember, we said we're going to double this, so maybe we need to make this a little bit bigger so it emphasizes the doubling. This is before doubling, and this is after doubling, before and after. And so intensities increases by 4 times. So we're going to see that I2 equals to I1 times, remember A2 is 2A1, so we're going to say 2A1 over A1, and this is square. These two cancel out. So finally you can get to see that I2 equals to 4 times I1. So the energy through the slit is not dependent on slit width. So you can see that I2 equals to 4 times I1. So once again, we had a problem where we assumed that the slit is going to be doubled. Initially, the slit was A1, and when it's doubled, it's A2, but A2 is double A1, and we want to see if the intensity, the initial intensity I1, becomes 4 times, the second intensity becomes 4 times the initial intensity. That's our goal. These are helpful diagrams for seeing the relationship between the intensity and the angle. So at an angle theta, we have a specific formula for the intensity, and that formula happens to be this one right here. Minimum intensity sine alpha over d But then alpha is the same as pi a over lambda. A is the width of the slit, theta is the angle that produces the intensity, and lambda is the wavelength. The amplitude is the initial amplitude times sine alpha over alpha. The amplitude is proportional to the slit width, and the intensity is proportional to the amplitude squared. Of course, this can be helpful because if that's the case, it's going to be like amplitude squared is going to be proportional to a squared. So, and since intensity is proportional to amplitude squared, it follows that intensity is also proportional to a squared. And that's why you're seeing that if we're relating two slit widths, A2 and A1, it's the same as if we're relating the squares. So I2 would be proportional to A2 squared, and I1 would be proportional to A1 squared, and that's why you're seeing this relationship. Since A2 is twice A1, you're doubling the slit width. And if we simplify that problem, we get to see quantitatively that that's true. So I hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day.